Okay, so we're back to actually take a look at what this model looks like what sort of happens over time here. So let's go back to our main sort of expression of this. I'm going to write this down on the next slide. If I can get my pens and pencils out of the way here. So we have this at any point in time, something that looks like that. Make sure I didn't leave anything off, right? And then remember that the G bar is defined as little z bar, little l bar, big L bar. Okay, so that is that's sort of the description of our model. So let's sort of switch over here to a spreadsheet. And this is shared with you in the version that I'm posting. This is a clickable link that goes to this Google Doc that I've now got shared with you. And so I'm just going to make a time column here. Let's just copy this down. Let's make a nice long, something like that. Okay, so we've got our time. Just get that kind of out of the way. And let's see, let's set up our idea accumulation relation. So let's do that first. So let's put that in the next column, but let's also sort of grab some space over here for our exogenous, if I can pronounce exogenous. Okay, our exogenous parameters. And so we need Z bar, L bar, or little L bar, big L bar, and A naught. Okay, so let's put those things over here. So we need Z bar. I'm going to call it ELL bar, right? The little L is ELL, and then big L bar, and then A naught. And let's just pick some numbers here. Let's say, I don't know, 100, oops, little L bar, maybe 20% or something like that. And we're going to have to play around with this. I'm going to play around with this one. In my experience, we need this to be a pretty small number. And the idea being that, something like that, maybe. The idea being that productivity of idea making, if we're extremely successful, if every experiment pays off, then our economy just sort of grows like a rocket. But of course, there's a famous quote from Thomas Edison, something along the lines of, "I haven't failed. I found 10,000 ways that don't work." Right. So this is idea productivity does not need to be high for us to make advances. So now what we want to do is I'd like to sort of set up the idea accumulation, and that's just going to grow. Think back to, maybe I should go back to the slides real quick. I'm not going to throw it in there, but the idea that we have this stock of ideas and it grows at G bar. And remember, what is G bar? Well, it's little z bar times L bar times big L bar, right? So this is where you can sort of see, like, if you chose some number like 0.1 for this, then you get like 200% growth rate, right? That's not very realistic. 20% growth rate. Let's do a 3% growth rate. I kind of like that. Okay, so we start off with our initial stock of ideas. And then every period, it grows, right? It's the initial stock. Actually, let's do it a different way. We take whatever we had the previous period and we multiply it by 1 plus G. I'm going to fix that reference. And this way, we don't have to worry about the time subscript or the time, right? We don't have to worry about a time. So this is a slightly different way of doing it. But this is also a valid way of doing this. And so we're just taking the previous one, right? We go from 1 to 1.03, which makes sense with this growth rate, 6.1, 9.3, right? We get this nice growth. So I'm just copying and pasting here. So let's just fill this down. Let's go all the way down here to the bottom. And I'm just going to fill down. This is Command D. Oops, and I wanted a little bit longer time series here. There we go. Okay, so there's our stock of ideas. So that's part of the puzzle, right? That's our stock of idea, or that's our idea accumulation relation. Let's make another one here. Wrong key. These are the proportion of the workers that are making stuff, right? So this is fixed. Sorry, it's 1 minus this, right? Is that number fixed? And in fact, that is going to be, oops, is that number fixed? Times the population. Copy, paste, paste, paste. Forgot to fix my reference. Okay, this is kind of boring, but we can just fill this down to sort of complete out. And I'm doing this because I want to build the different pieces of the of our sort of production function. I want everything to sort of show up here. So that now tells us, right? That's basically what we have here is the production function, and we can do that to get, right? We can work with this. Remember, it's just these two guys multiplied together. We just take A times LYT. There we go. There's our GDP. But what we're usually interested in is per capita GDP. So we can just take this, divide it through by L bar, right? That's our total. And I forgot to fix our reference again. It's always good to sort of check yourself here. There we go. So this looks pretty good. So there is our time path of per capita GDP. Let's make a nice little plot of this. And there we go. Now, we could play around with this. We could say, oh, what's going to happen, right? What if we had like a few more workers? Or what if we had a smaller labor force? Notice that when I change these, move these out of the way. When I change these, G bar is changing. This is changing the growth rate. So it's changing the level of output and it's changing the growth rate. So this is interesting. In fact, this has some implications for how this economy is going to grow based on these exogenous parameters, right? We can play around with a lot of these. Okay, that is about the right amount of time for a video like this. So we will pick up with this in the next video.